students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing the chapter called as gravitation. Take down please. The binding energy of a satellite is 4 into 10 raised to 8 joules. The binding energy of a satellite is 4 into 10 raised to 8 joules. Calculate the kinetic energy and the potential energy. Calculate the kinetic energy and the potential energy. Calculate the kinetic energy and the potential energy. Now we know that binding energy is nothing but negative of total energy. Binding energy is negative of total energy. Therefore, I can say that total energy is minus binding energy. Therefore, I can say that total energy is minus 4 into 10 raised to 8 joules. Right? But total energy is also given by the formula minus GMM upon 2R. Therefore, I can say that minus 4 into 10 raised to 8 is minus GMM upon 2R. Therefore, I can say that GMM upon 2R is 4 into 10 raised to 8 joules. Right? Now, once I have this, kinetic energy, guys, is given by the formula half GMM upon R. Half GMM upon R, which is same as GMM upon 2R. Hence I can say kinetic energy is 4 into 10 raised to 8 joules. Potential energy is given by the formula. Potential energy is minus GMM upon R. Therefore I can say that this is nothing but minus 2 into GMM upon 2R, which is minus 2 into GMM upon 2R we already know is 4 into 10 raised to 8 joules. So this is minus 8 into 10 raised to 8 joules. So thus you know total energy, kinetic energy and potential energy. Fine. Take down next one please. Find the total energy and binding energy. Find the total energy and binding energy of an artificial satellite of mass 100 kgs orbiting at a height of 1600 kilometers above the Earth's surface. If the mass of Earth 1600 kilometers above the Earth's surface, if the mass of Earth is 6 into 10 raised to 24 kgs, radius of Earth is 6400 kilometers, and G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Now let's see this. They've asked you to find out the total energy and the binding energy. Straightforward. Total energy, we just did this, is nothing but minus GMM upon 2R plus H. All the values are given to you. G, M, M, R, H. Straightforward substitution, you should get the answer. Once you have total energy, then you can find out binding energy. Binding energy is negative total energy. So you should be able to get the binding energy. The answer for this sum should be, total energy should be negative 2.501 into 10 raised to 9 joules, and binding energy will be 2.501 into 10 raised to 9 joules. Next, take on next one please. the escape velocity from Earth's surface, the escape velocity from Earth's surface is 11.2 kilometers per second. The escape velocity from Earth's surface is 11.2 kilometers per second. If mass of Jupiter is 318 times the mass of Earth, if mass of Jupiter is 318 times the mass of Earth and the radius of Jupiter is 11.2 times the radius of Earth, find the escape velocity from Jupiter's surface. Find the escape velocity from Jupiter's surface. Now we know that, guys, escape velocity is nothing but square root of 2gm upon r. Hence, I can say that escape velocity is going to be directly proportional to square root of m by r, because 2 and g are constants. So I can say that escape velocity is directly proportional to square root of m by r. Therefore, I can say that escape velocity from Jupiter upon escape velocity from Earth is nothing but square root of mass of Jupiter upon radius of Jupiter upon square root of mass of Earth upon radius of Earth. Therefore, I can say escape velocity from Jupiter upon escape velocity from Earth is nothing but square root of mass of Jupiter upon mass of Earth into radius of Earth upon radius of Jupiter. Right? Square both the sides, or you could just take this. Escape velocity from Earth is given to you. So you can say escape velocity from Jupiter is nothing but escape velocity from Earth into mass of Jupiter upon mass of Earth into radius of Earth upon radius of Jupiter. Substitute the values and you will get the answer. The answer for this sum should be 59.68 meters per second. Next. Earth moves round the sun. Earth moves round the sun in a circular orbit. Earth moves round the sun in a circular orbit of radius 1.5 into 10 raised to 8 kilometers. 1.5 into 10 raised to 8 kilometers. Calculate the binding energy. Calculate the binding energy if mass of sun is 2 into 10 raised to 30 kgs and radius of Earth is nothing but 6,400 kilometers. They've also given you that G is 9.8 meters per second square. Now, binding energy of the Earth is nothing but G mass of Sun into mass of Earth upon twice R. Right? Now, I know MS, I know M, mass of Earth is not given to you. They only give you mass of the sun. Now, for a body of mass m, on Earth, I can say that the weight of the body mg is nothing but gmm upon r square, right? So in that case I can say m and m gets cancelled. In that case you will get that mass of Earth g into r square is g into mass of Earth. If I substitute this there, I'll get therefore binding energy is mass of Sun into gr square upon 2r. G into mass of Earth can be substituted this way. Once you have this, you should be able to get the answer, because g, r, mass of Sun and radius all are given to you. You should get this answer. The answer for this sum should be 2.676 into 10 raised to 33 joules. Next, let's see the next sum, guys. A body is raised to a height of nr. A body is raised to a height of nr from the surface of the Earth of radius r. From the surface of the Earth of radius r. Show that the ratio of the acceleration due to gravity on the surface to that at height h is nothing but is n plus 1 the whole square. Now, gravitation G on surface of Earth. G is given by the formula gm upon r square, right? G at height h above the surface can be given by the formula gh is gm upon r plus h the whole square. But what is the value of h given to you? The value of h is given to you as nr. So I can therefore say gm upon r plus nr the whole square, right? This can be written as gh is equal to gm upon r common 1 plus n the whole square. Therefore I can say gh is gm upon r square into 1 plus n the whole square, right? They've asked you to find out the ratio of g to gh. Therefore ratio of g to gh, g is nothing but gm upon r square upon, this is nothing but gm upon r square into 1 plus n square. Therefore g to gh is nothing but 1 plus n the whole square. Gm and r square gets cancelled, denominator of denominator becomes numerator. Next, let's see the next sum, guys. Calculate the gravitational force. Calculate the gravitational force between two metal spheres calculate the gravitational force between two metal spheres weighing 4 kgs each, weighing 4 kgs each, and 0.2 meters apart, and 0.2 meters apart. If G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Straight by Newton's law of gravitation. F is equal to G m1 m2 upon r square. All the values are given to you straight multiplication. You should get this answer as 2.67 into 10 raised to minus 8 newtons. Next, take our next one please. A wooden block of mass m, a wooden block of mass m, a wooden block of mass m is raised to a height of h, is raised to a height of h from the surface of the earth. Prove that the loss in weight, due to variation of g, prove that the loss in weight due to variation of g is equal to 2 mgh upon r. Now, guys, the acceleration due to gravity at height h from the surface is given by g bar, which is equal to g 1 minus 2h by r. Right? Now, if I multiply both sides by m, so I'll get mg bar is equal to mg1 minus 2h by r. Right? Do we get this? Now, in that case, therefore, what will be the change in weight? Change in weight of the body. Weight of the body at height h is this. Weight of the body on the surface is mg. So it will be mg minus mg bar. That is going to be the loss of weight, which is going to be nothing but mg minus mg 1 minus 2h by r. Right? So my change in weight is going to be nothing but mg 1 minus 2h by r. So this is going to be mg 2h by r, which is nothing but 2 mgh by r, and that's what you're doing. Right? Take our next one please. What will be the value of g? What will be the value of g at the bottom of the sea? What will be the value of g at the bottom of the sea, 2 kilometers deep, 2 kilometers deep, if G on Earth's surface, if G on Earth's surface is 9.8 meters per second square and R is 6.4 into 10 raised to 6 meters. Gravitation at depth G is given by the formula G bar is G1 minus D by R. Straightforward formula D, G and R, all three you have. All you have to do, substitute and get the answer. Your answer in this case should be 9.797 meters per second square. Next, take down next one please. How much deeper from the surface of the earth? How much deeper from the surface of the earth does the acceleration due to gravity? How much deeper from the surface of the earth does the acceleration due to gravity becomes 70% of its value on Earth's surface? Becomes 70% of its value on Earth's surface if the diameter of Earth is 12,800 kilometers. If the diameter of the Earth is 12,800 kilometers. Now if diameter is 12,800 kilometers, that means radius will be 6,400 kilometers. That is 6,400 into 10 raised to 3 meters. Now they have asked you to find out at how much deep. Gravitation at depth is G1 minus D by R. Therefore I can say that G bar upon G is 1 minus D by R. You know the value of G bar. G bar is 70 upon 100 into G upon G is 1 minus D by R. R you know is 6,400 into 10 raised to 3. G gets cancelled. 70 upon 100 is equal to 1 minus D upon 6,400 into 10 raised to 3. You have all the values. The only unknown here in this equation is D. You should be able to get the answer of D. The answer for that should be 1,920 kilometers. You will get this answer as 1,920 kilometers. This finishes this chapter. We will stop this here for the day. Thank you very much.